Okay, so as we said that in V belts, the number of belts will be greater than or equal to the design horsepower divided by the allowable horsepower. Let's say, for example, it's very easy for this case when you have the design horsepower is 10 and the allowable horsepower is 5, so that is 2 belts. Fine. But what if you have the design horsepower HD is let's say uh, let's say if that is 6, right, and your allowable horsepower is 4, then what is the number of belts? What will be your NB equal to?
2 by 3.
2 by
Two.
kitne?
3
Two.
by 2.
It will be equal to, okay,
1.5.
4.1.5, 1.5 हो जाएंगे. Acha. So the number is greater, it is 1 point something, right? 1 point something, या 2 point something अगर आ जाए, या 3 point something. If it is not an integer, that means, देखिए, you cannot split a belt. Therefore, if it is 1.2, 1.3, even 1.1, 1.1 अगर आपके पास हो, तो you should go for the higher number. Therefore, in this case, your belts will still be, if we go for a higher number, your number of belts will be 2, let's say. Now, generally, not only V belts, but generally आपके belts जो belts transmission systems होते हैं, they are over designed. ठीक है जी. With 2 belts you can transmit more than 6 horsepower. लेकिन you cannot have 1.2 belts or 1.3 belts or 1.5 belts. It should be an integer. So if it is 1 point something or 2 point something, you switch to the next higher number, and that is why we say that NB should be greater than or equal to HD over HA. Okay.
एक्सक्यूज मी सर।
जी.
सर ये अगर एन बी 1 से ज़्यादा 1.2 आ जाए 1.3 आ जाए तो बजाय इसके कि हम 2 बेल्ट यूज़ करें अगर हम दूसरा सेक्शन इस्तेमाल करें तब सर तो
Yes,
वो हमारा
very good, very good that you pointed this out. You can switch from this section to this section. That is fine. You are the designer, and as I say that this, okay, in design you have to decide, are you going to keep this A section, or you want, instead of using 3 belts, you say no, I want to switch to section B section. That is your decision. ठीक है जी. So you either switch the section or you use more number of belts. Okay. These are the suggested service factors for V-belt drives, as you know, light shocks, uniform, medium shocks, heavy shocks, and so on. As far as the design is concerned, again, you will have, the tension for the V belts, F1, F2. You can calculate those using these equations. Factor of safety, just because you have the number of belts over here, if that is 1, then you don't need this. It will still be the same equation for the flat belts. But if you have the number of belts, then your NFS is equal to this, which is equation 17-26. Okay. You can also actually the number of how do you measure, okay, this belt will be the life of belt, life of a belt. Okay, you can measure the life of a belt in 2 ways. One is revolutions. For example, there is a belt over here, right, which is between these two pulleys, and you start, from here, note this point, and this point goes and come back to this point. That is one revolution, right? So how many revolutions will it do? That is one of the counts. You can also, measure it in hours, right? That how many hours a belt would work. But again, with hours, you need to also give information that how many um, revolutions per hour. So basically, it turns out to be revolutions again, because revolutions per hour and operations in hours. So that will cancel with each other, and again you will be left with revolution. So it is one of the same measurement, but you can go ahead and find that from here. These are the formula given to you. Okay, the number of the time that that a belt would work for. Um, um, so go ahead and see, okay, what will be the number of passes, yeah, the number of revolutions that a belt can withstand with a certain amount of tension in the belt. Okay? So I will, leave that on you to look for the equations 17-27 and 17-28 in your book. There are some. Acha ji, again, let's have a look at this problem. It says that a 10 horsepower split phase motor running at 1750. So देखिए horsepower is given to you, that is 10. The N is given to you, which is 1750 revolutions to drive a rotary pump, and that operates 24 hours a day. ठीक है जी. So this means that it's a tight situation over there. An engineer has specified 7.4-inch small sheave. So D is 7.4 inches, and 11-inch large sheave. So capital D is 11 inches. And 3 B112 belts. So the belts that are used is B112, and NB is 3. The service factor is 1.2. Service factor दिया गया है. KS is 1.2. Was augmented by 0.1 because of the continuous duty requirement. तो वो कहता है कि this was augmented by 0.1. So the service factor is basically 1.3 total. ठीक है जी. Analyze the drive and estimate the belt life in passes and hours. Okay, we will do that. First of all, go ahead and find your speed V, that is pi dn by 12. Okay, so that is your velocity. From the equation 17-11, find your length of the of the belt, the pitch length of the belt, which is LP, L plus LC. Okay. Similarly, go ahead and find your center to center distance, which is 17-4 inches, putting in the values. Okay. And then follow the same procedure. Okay, सबसे पहले what do you do is find your phi, which is theta d, pi minus 2 sine inverse of d minus d, and so on. So this is your phi. And then with that, you go ahead and find your exponent of f phi. You already have your f, which is 0.5123, and then your phi is 3.057 radians. So plugging that value, this is the exponent of f phi. Okay. interpolating in table 17-12 V is this, so you find your H tab. ठीक है जी, H tab, this is the tabulated horsepower which is 4.693 that the belt can transmit with looking at the speed too. A angle of wrap in degrees, you just convert this into degrees. ठीक है जी, 180 by pi से आप multiply करेंगे. The correction factors from table 17-3 and 17-14 are given to you over here. So आपका allowable horsepower क्या होगा? K1, K2, H tab. So this is your K1, K2 and H tab is given to you. You just found it out with your interpolation. So this is the allowable horsepower. Now H design आपका क्या है? You already have the horsepower from the problem statement, which is 10. ठीक है जी, तो what you would do is 10 multiplied by the service factor Ks and Nd. Nd is 1, taken 1 over here, that is fine, and it turns out to be 13. Go ahead and find the number of belts, which is 2.67, and that turns out to be 3. ठीक है जी. From table you find your Kc and then your Fc, delta F. ठीक है जी, the difference between the two tensions. Go ahead and find your F1, F2, Fi the same way as we did for the flat belts. And F यहाँ पे आपने 3 डालना है because your HA is 3 times now because there are 3 belts used. So that turns out to be 1.13. Life, just use equation, वही equations जो अभी मैंने आपको दिखाए, just use those and you will find out the number of passes या the hours, which is 46,600 hours. ठीक है जी, तो ये अच्छा जी. As far as timing belts are concerned, timing belts are similar to V belts. The only thing is कि first of all you don't have Fi in here. ठीक है जी. Why no Fi? Because देखें, if you stretch this, this pitch is going to be disturbed. यहाँ से लेके यहाँ तक, this is the pitch of this. If you stretch this pitch is going to increase, so this will be P plus delta P then, right? So therefore you cannot have Fi in timing belts. The rest of the things के स्टैंडर्ड अवेलेबल है, एक्स्ट्रा लाइट, XL लाइट, XH है, extra heavy, extra heavy, and these pitches are available in timing belts, and you can design them in the same way as you design your V belts. ठीक है जी, तो